Welcome to the next video in our 3D printing for remote control series. In this one we're going to talk a little bit about the common gotchas that you can come across when you first start to 3D print. And of course we're assuming that the printer's been set up correctly, that you've gone through your calibration and that you've initially started to print and your 20mm test cube that you printed has come out okay. But then some of the things that you've been printing after that are coming out and looking a little horrible. So what we're going to do is talk about some of this stuff, and we're going to go through it at a reasonable pace. The last videos in the series will be looking at things like more exotic filaments and then delving more into actually changing models that you've downloaded from the internet and some other quick tips too. So the first thing we'll talk about then is be careful when you're actually designing your own print. Too much complexity in a part can increase the print times, but also increase the chance that something's going to go horribly wrong. As we talked about in the previous video, this was my very first attempt at a wrench to undo the screws on the top of a 250mm class quadcopters, and it printed okay, but I wasn't particularly happy with it for two reasons really. One, I didn't test print my hexagonal hole here, so it wasn't exactly perfect for the 10mm spanners that I was trying. Also, I didn't have enough layers on the top, so it only printed two, and I was using a very open internal fill, so you can actually see the imperfection here on the top of, you can kind of see the hexagonal big holes that are inside here. It's like a honeycomb. Now if I'd have put another layer on top, that would have printed nicer, but what I realized by printing this one is actually it doesn't need to be this big. And also sticking it in the bag where I keep my propellers, having this stuck up bit isn't great. So then I revised it through numerous different versions to get down to this little one, shallower. It's just one simple kind of 5-6mm thick piece with exactly the right size hole because I tested it, and it also has a little thumb depression and a little hole at the end so you can mount a stick in it as well, so you can actually do the smaller props. So that's a great example of too much complexity making a part print not great. I didn't do some great choices with picking things like the slicer, and the choices that you make in the slicer about the number of top and bottom layers and the number of the amount of fill and other pieces too will dramatically change how the part comes out. Do think about the way that your design software works when you're starting to design your piece of technology. Now I sometimes will get stuck in doing things in SketchUp where I want lots of nice sweeping curves and designs, and I find it a lot easier to design those in things like 123D or vice versa, or some of the other software that we use here. Have a think about the part that as you're designing it, think about how many curves, and then once you get to know your software a little bit better, you'll have a much easier way of trying to figure it out. For this part that we've designed here that's printed horribly, and we'll come on to that in a minute, it was actually a clip that was going to go on one of the vertical pieces of the printer, and this face here was to put the LEDs on. So similar to the strip LEDs that we add onto our 250 racer quads, I was going to put a little 9cm strip on here to illuminate the print bed, so in the evenings when it's printing, rather than me have to kind of have the big lights on all the time, I can sit here in the study with my lamp on the desk and the 3D printer running in the corner with the bed illuminated, so I can make sure everything's going okay. Now the way I printed this was actually vertically, but the way I designed it, I actually designed it as a stand-up piece as well, and part of the reason that it hasn't printed out is because it's been printed in the same way that I designed it. So I first of all designed or drew a very big thick column, then I kind of cut out my 10.1mm hole and pushed that out the bottom, and then I kind of sliced a piece off so that it was at a slight angle. Again, I don't need the angle. I've printed this and it turned out horribly, so in version 2 we actually have it's just a flat face with these kind of pieces going around each side that go around the outside of uprights that are on the printer, and it works brilliantly. So I managed to talk myself out of a nice easy print by trying to be too clever again. Do think about the way the printer works. Mine, for example, is very good and very quick, but it will do a nicer print when things are reasonably long to print. So for example, this is a vertical piece here. You can see all the striations of all the different layers, and it's worked fine. One of the reasons it's printed so nicely is that I've had lots of material, which allows the print head, by the time it's up this end of the print piece, the other end has cooled down, so as it comes back around, the layer before it has time to solidify and be absolutely fine. The problem that we had here was that because there wasn't enough material, I was actually catching the still soft plastic underneath and dragging it around the corner every time my head went around it. So that is a much easier way to print if I'd have printed it with that part down, and then these big long pieces would have been printed as it went up, and that's actually how the second piece that I designed was laid on the print bed as well. I was trying to be clever and make the part as strong as I possibly could, but there's no point in having a really strong part that looks like that and won't do the job it's designed for. Do test print stuff. I found that I'll spend time accurately measuring everything, and then when I print it out I'll find that I'm actually slightly out. There's a very old adage about measure twice, cut once, and it works the same for 3D printing. And that's because what this circle actually is it's actually got lots and lots of flat sides, which is how SketchUp actually designs it. And each of those flat sides actually means that the internal diameter is slightly smaller. So I adjusted for that and printed it out, and it works perfectly the second time. And that is the one that's actually on SketchUp. You can download it and print it. So it would have been easier for me, and this part kind of taught me this, if I'd have just printed a test print, a loop, to make sure I had it the right size, then I could have saved myself all the time printing this, and it would have worked fine. In fact, an illustration of that is here, as we've looked at before, is the piece that goes on the front of a Hobby King Sky Surfer. It's the front nose piece. This will be a flat piece of perspex here, and it's designed to protect the camera and also provide a nice sunshade. And you can kind of see here how much nice shade it provides under this little lipped canopy. I wasn't sure about this dimension, so I test printed the circle diameter that I thought it was from my measurements, a little bit of PLA, just 4 or 5 millimeters high, stuck that on the model, was absolutely sure that that was the perfect size. Once it was, then I went back and printed the real piece. So I would always say consider the first version of any model that you make a test model, because things will go wrong and either the printer will goof. So here is one where, because I was printing a very small area, and this was the only part of the print that was being printed, so it was going over and over and over this piece, and the PLA plastic didn't have time to solidify, so it was just getting pulled and pulled around and end up looking like this horrible kind of thing that looks like a load of black cotton wrapped around itself. The way to get around this is two things. One, you can either design a part that has a little bit of a wider gap. This has a lot of wider gap, but that it also worked better. And also you can reduce the speed of printing. A lot of printers allow you to slow down the print head, and what I would do with this part is I would actually print it at probably 70 to 80% of top speed, so that as it came up into this very thin piece that rose, it wouldn't overheat the piece and would allow the plastic to solidify and cool before it was printing the next layer. And in fact, we can show that on this piece here. So the common problems that you will get scruffy looking prints, and as you can see here at the bottom there's a lot more material, and it's because of the slope that I tried to design into the part, there's a lot less material at this end. And because of that, because of all the infill and stuff that the printer was doing for this larger piece, as it was printing the first part of the model, it wasn't doing a bad job. It wasn't perfect, there's a couple of little hiccups, but it was doing okay. Until it got to the part about here. And what happened was, because the PLA plastic hadn't cooled, it was starting to get pulled around the corner by the next layer, and it started to go horribly wrong. Now, there were two things that you could try and do to make this a little bit better. The first thing I did was actually put a fan onto the PLA so it was setting up, and that's what that little centimetre here by my thumb is. Or the other thing you can do is then, and let it kind of go back, because I wasn't actually it wasn't my fan, it was me blowing on it, if I'm being honest. And then here it kind of went back to being horrible, because all the time it's going up, the material is getting less and less, the more and more heat is in the piece, and less time for it to be dissipated. And then the very top part, which is kind of almost back to where it should be, I reduced the print speed to 80%. Just clicked the control and went into the menu on the LCD screen and just slowed it down. In fact, I could probably slowed it down to maybe 60% and it would have probably worked even better. So that's a great example of what can happen with a scruffy print. So reduce the temperature in the nozzle would help stop that. Just take it down another 5-10 degrees, gives the part a little bit more opportunity to solidify. Reduce the layer size. So what I mean by that is reduce the amount that you need to print each time. So rather than trying to print 0.2, try 0.1 and 0.3. It might make a difference. And the last thing, of course, is do slow it down. Make sure your printer's going a lot slower for these really small, intricate parts. Do be careful as well when you're designing that you don't put enough material around key joints. We've looked at this part in one of our previous videos. This piece that was supposed to hold the front of the part that I was making just completely snapped off the first time I tried to use it. Now, as it happens, I wasn't going to use it properly anyway, because that looked horrible, but you can see how cleanly it snapped off. It hasn't got enough material around there. Now, what I did for the second version of that is we used this part. So that is version 1. That's version 2. So you can see we've completely redesigned the front bit and it works an awful lot better. This time the delamination was here at the back, and it's actually not delaminated in the same way. It's actually that whole outside piece it's still connected to that's come across. So what I did then was widen this piece a little bit and also put some more plastic on this side, extruded this piece backwards slightly, and it worked perfectly. The printer can wander out of good calibration, so occasionally you'll go to print something and you'll notice that it won't be great. Do redo your calibration once every month, I'd recommend, just to make sure that you're still absolutely fine. All the printers that do auto calibration at the start will be great, but over time the belts can get a little bit slack. It might be that one of the screws that's setting up the height of the print bed might have rotated slightly with the vibration of the prints, so do make sure that that's okay. Some more common problems, do make sure that you're using the right plastic for the job. I would always use ABS for those high impact places on things like remote control quadcopters and others. PLA is just too fragile and it will snap if it gets hit hard enough. If you make it so that it's stiff enough to take the knocks, then it becomes slightly brittle. The other thing to think about then is weak prints and delamination. Consider the print direction. Now, the reason that I actually printed this piece here that turned out so horribly, and the reason I printed it vertically like that on the print bed, is because each of the layers of plastic would be the strongest possible as I snapped it around the 10mm upright. And as you can see, sometimes things will delaminate, so they'll always tend to come apart where one layer meets another. So if you think about that when you're designing it and also printing it, you can have the strength in the right direction. Now the problem with this one, of course, is that I didn't leave myself enough material, so we had these problems with scruffy printing. But that is the strongest way for me to print a part like this, because as I pull these pieces apart to get them around the 10mm pole that they're supposed to be snapped onto, there's less chance of one of the laminations on its back giving up and me snapping it off. Now the version 2 of this print that I actually used, I reduced the amount that these pieces came round slightly so they're almost completely straight on, so that when I snapped it on there wasn't a chance of me breaking off one of these side pieces, and it worked fine. But again, that was a compromise and something I had to consider, but it's also something you have to be aware of, that there is more strength in a part in one direction than another. If things are delaminating, like we've seen on this part, you can try and increase the temperature so that the plastic is a little bit more liquid and we get a better bond. Or if it's still doing it, then my advice is go back to the first thing we talked about here, try another plastic. The one you're using might not be strong enough. It usually means that using PLA when you need to use ABS. Last thing we'll talk about then is damaged STL files. As we looked at in the previous video, a lot of the time that you'll spend in things like SketchUp, you'll design some beautiful parts that you then want to go and print, and when you put them into things like Repetier Host and your slicer, you'll get errors, particularly those you've downloaded from Thingiverse. Use things like the 3D file fixing service from Microsoft. There are other online ones as well. It's the fastest and quickest way to get things sorted, and sometimes there'll actually be problems that the software won't pick up, and when you go to print it, you'll notice that one of the elements hasn't printed very well, and that's usually down to the fact that you've got a problem in the file and the slicer's done its best, but it's had to kind of interpret what that geometry is all about in the STL file, and it's interpreted it wrong. So use those services to make sure that you've got your best chance. So hopefully that'll help those of you that's looking to do 3D printing. My summary would be, your first print I would suggest of any item is always going to be a test print. Have a look at how well it's printed. Is it strong enough? Is it printed in the right direction? Is it delaminating? Does the temperature look right? Does the material look like it's adhered well? Is the design the best that you can possibly make it? Are there improvements, ways that you can simplify it so that the part looks better and functions better too? If you're not sure about any dimensions, test print them. Print a little bit of plastic, stick them on the model, make sure that it's the right dimensions and it's all going to work before you invest time and effort printing the main part. That tip is the one that I would probably say is top of my list, particularly for remote control where we're adding these pieces to other elements, because otherwise you can spend an awful lot of time, effort and filament and end up with paperweights. Thank you for taking the time to watch that video. There are lots of other videos on the channel and they're carefully ordered into playlists, so you may find that there are other videos on this same subject that you can go and watch. So I would recommend going into the playlist area of Painless 360 YouTube channel and looking around and seeing what there is. You never know what you might find. Thanks for watching. Please like, subscribe and happy flying.